In this video, we are going to look at how to use ANSYS Workbench to do heat transfer problem. And we look at this question here, which is a fin with thermal conductivity 200 watts per meter per degree. It's shown in this figure here. On the left, is subjected to a prescribed temperature 300 degrees, and the front and the back walls are insulated. Top, bottom, and the right surfaces are subjected to convection with ambient temperature 30 degrees. In ANSYS, we need to do a steady state thermal analysis. First step is to define materials. So we need to define a new material, just call this material, and define the thermal conductivity, which is 200 watts per meter per degree. And we need to do geometry next and choose design modeler. So according to the figure, in a design modeler, we are going to create the bottom surface, which is 0.06 meters long and 0.1 meters deep, and then extrude to a solid, which is 0.003 meters thick. So we are going to create a sketch in XY plane. First, we need to adjust the scale. And possibly here, and do a sketch rectangle. So this rectangle will sit on the global x-axis and set the dimensions. The length is 0.06 and the height is 0.1. And we'd like the rectangle to be symmetric about y-axis, so we can use constraint, symmetry, and the left edge and the right edge. So after this, we go to modeling and do extrude sketch 1, and the depth 0.003 in meters. So this is the geometry, and in order to locate the midpoint, and we're going to slice this solid by YZ plane, and then combine these two bodies into a new part. So then close design modeler, and update the model. Now double click to open ANSYS Mechanical. So in here, we need to first set the material. So to material that we defined, and just use the default mesh and apply boundary conditions on the left surface that is a prescribed temperature 300 degrees, and the top, bottom, and right surfaces are subjected to convection. So according to the question, that the convection coefficient is 200 watts per square meter per degree, and ambient temperature is 30 degrees. So in here we enter 200. So make sure we are using the correct units. So here we need to change to meters. So that would be 200 watts per square meter. And ambient temperature is 30 degrees. And for the results, we insert temperature, and first look at in the middle T2, so we can hide one of the bodies, so to get the temperature on this surface, and we can duplicate and show body to get the temperature on the right surface, and we can get directional heat flux in the x direction, and on the left duplicate, and on the right. Then we can solve the problem. So now we can look at the temperature like T2, T3, and heat flux. So we can also look at the temperature distribution and heat flux distribution as contour plots.